This is the fourth video for sample exam number 3 for Math107. This is about solving a nonlinear inequality. This inequality right here is nonlinear because the x is squared. So here's how you do this. You solve this as though it had an equal sign in it, and you find two values of x. So if I say x squared equals 12, then what are the potential values of x? I'd have to take the square root of both sides, and I could find out, you really only need one plus or minus sign. It's plus or minus the square root of 12, right? Because if I square plus the square root of 12, I get 12. If I square negative square root of 12, I get 12. All right, so now I find those, and the idea is graphical. Here's my 0. Here's the square root of 12. Let's say it's here. And I have minus the square root of 12. Now those two numbers break up the number line into three regions. We have a region that's going between the numbers here, and we have another region out here. And actually I could do this in the same color, but I'm not going to. Let's just look at it like that. Now the other thing I know is that because this inequality is strictly less than or strictly greater than, these numbers aren't included, so the endpoints aren't going to be included. Now the question is, which regions satisfy this inequality? And if one number in the region, like for example, if the 0 in the red region satisfies this inequality, the whole region satisfies it. If 0 fails, the whole region fails. So you pick a test point, and you need to pick some test points to get credit. So I'm going to look in the red region, and obviously pick the easiest number. I'll pick x equals 0 for a test. So I put 0 into this equation, and I say 0 squared minus 12. Oh no. 0 squared greater than 12. And the answer is no. That means this whole region fails. Forget it. So go over to these other regions and pick a test point here. And again, always pick something easy. This one's blue. So I'll go over here and pick the point 10 because I know I can square it pretty easy. Put that in the equation. So here's my second point, x equals 10. I used 100 over here for this example, but it doesn't matter. 10 squared. Is it greater than 12? Yes. 100 is greater than 12. That means this whole region is a yes. And actually, it's going to be either the inside region or both outside regions, for reasons I'm not discussing. Right, but to be thorough, go over to this region and pick minus 10, and you'll get the same results. It turns out to be a yes. And now you have to write the solution in a certain way. Right, I'm going to erase some of this so there's some room. Alright, so I want this green region over here. It starts at negative infinity, goes all the way up to minus root 12, which you can write differently if you want. It doesn't include it, so I put a parentheses. Then I have to jump over all this and start up again, so I put the set union, start at 12, square root of 12, but again I don't include it. That's why I put this open parentheses here, and it goes all the way to infinity. Here we're talking about proportionality, and I should have used the word direct, but okay, two ways. If it's directly proportional, for example, if power is directly proportional to velocity, power equals, now it's proportional, not equal exactly, so you have to put a k. The k has to be here. Then say it's proportional to v, well, I'll use the problem up here, v cubed. That's directly proportional. For example, if you had inversely proportional, the word inversely in it, then you would have to write it in the denominator. This is inversely proportional. This is directly proportional. Okay, and if there's no directly, it's usually assumed. Okay, so here we've written the equation. It better have a k in there, because power is not equal to velocity cubed. K is needed, if nothing else, to change the units. and also to rescale the answer. This means the power is proportional to velocity cubed, not equal to it. And that's your equation right there. You've got to have a k in it. Now what's the value of k? To find k you need one data point. Say it generates 15 watts if the wind's blowing 10 miles an hour, and let's say that we can use that data. So we put the 15 here because those are, let me show you again. Okay, if you don't know what to do, write your equation. Hopefully you've written it right in the first place. Now, substitute the numbers. 15 watts equals whatever k is, and now I've got 10 miles per hour cubed. Okay, so how do I find k? I isolate it. K is equal to 15 in this case divided by 10 cubed, which is 1,000. Right, that's all there is to do there. Now there are a couple things I like. I like piecewise functions, and I like these kind of thinking problems where you look at how one thing changes if something else changes when you have the basic equation. This isn't about just coming up with a number. It's about seeing a trend. So we had this equation here. We had that the power was equal to, I don't care what the constant is, just leave it alone, v cubed. And the idea is, say the wind speed tripled, how much power would be generated? Right? Say this is how the power is right now. Okay, I don't care what p is. We'll say this is your original, so we'll put the 0 on the end of it. Right. Now let's triple that wind speed. K, and tripling it means you've got 3 times the velocity, right? And then you have to cube all this because this is your new velocity. That becomes k. Tripling that would be a 27 v cubed, which I can write as 27 kv cubed. Kv cubed was your original velocity because that was your original power, so this is 27 times greater than your original power. Okay, now this is triple. Oops. Triple the wind speed. Oh, do you see that? You have your equation here. If you're going to triple it, you put it in as 3 v, and then you cube that whole thing and you get to 27. What happens if it's doubled? So now if we double it, we'll do the same thing. Here's my original problem. Whatever k is, I don't care. And here's my velocity cubed. Now I want the velocity to be doubled. This becomes twice what it is. Put that in the equation and see what happens. 2v cubed. Well, when I cube the 2, it's an 8. So this becomes 8v cubed. That means you get 8 times more power. So this whole idea of seeing the trend. If I double the velocity, I don't just double the power because it's raised to the 3rd. All right? If it was like this, P equals, say you have a particular windmill, and K times V, if I double the velocity, so the velocity is doubled, in this case the power is doubled. If I triple it, so I'm going to triple the velocity, then I get 3 times the power. That's for this case here. Now if it's cubed, it doesn't work that way. If I double it, I get 8 times the power. If I triple it, I get 27 times the power. So obviously that's a much better design.